So you're diving into the world of Go, huh? Awesome. One of the first things you'll bump into is how it handles groups of data. It's a little different, but trust me, it's incredibly powerful. Today, we're going to break it all down. Let's get right into it.
Okay, let's be real. If you're coming from Python or Java or pretty much any other big language, this question hits you almost immediately. You know the drill. You need a list, a dictionary, a set. You open up Go and you're thinking, wait a minute, where's everything? It can feel like something's missing, but I promise you, it's not. There's just a different, really elegant way of thinking about it.
And that's exactly what we're going to do today. Think of me as your personal translator. We're going to take the concepts you already know and love and just map them over to Go's way of doing things. All the power you're used to is there. It just goes by a different name.
All right, first up, the absolute workhorse of data collections, the list. In the world of Go, we don't really say list. Instead, we have something that's, well, even better.
I want you to meet the slice. This is Go's answer to the list, but it's more like a list on steroids. The two big words here are flexible and dynamic. Unlike some languages that make you deal with fixed-sized arrays, slices can grow and shrink whenever you need them to. That makes them perfect for handling collections of data that change over time.
So how do you make one? It's super simple. You just use these empty square brackets, tell Go what type of data you're storing, in this case integers, and then list out your values. Boom. We've just created a slice called numbers holding our 4 integers in order.
Now what if you want to add something? Go has a built-in function for that called append. You just tell it which slice you're adding to and what new value you want to stick on the end. The cool thing is it actually gives you back a new slice with that item added. It's a really clean and predictable way to grow your collections.
Okay, so we've translated lists into slices. Easy enough. Now, what about that other must-have tool, the dictionary? You know, for when you need to store data with a unique key, not just by its position. In Go, a dictionary is just called a map. The idea is exactly the same. It's a collection where you store things as key-value pairs. This is your go-to for super fast lookups, like getting a user's email by their username, or, looking up a product's price.
And here's how you declare one. We're making a map called prices. This map string float64 part just tells Go, hey, my keys are going to be strings, and the values I'm storing will be numbers. So here, coffee is a key, and 2.5 is its value.
And adding a new item? Oh, it's so beautifully simple. You just use the square brackets with your new key, in this case water, and assign the value. That's it. No special functions needed. If water isn't in the map, it gets created. If it is, its value gets updated. Simple, right?
Okay, so lists are slices, and dictionaries are maps. But what about the other guys? What about sets for when you only want unique items? And what about tuples for grouping a few different things together? Now this is where Go's philosophy really starts to shine. It doesn't just add more types, it uses the tools it already has in a really smart way. So check this out. Go doesn't actually have a built-in set type. Instead, we pull off this really cool trick using a map. We create a map where the values are just booleans, true or false. The value doesn't really matter, we're just using it as a placeholder. What we care about are the keys, and since a map, by its very nature, can't have duplicate keys, it automatically gives us a set. How clever is that?
And tuples? Same story. Go doesn't have a specific tuple type, but it has something that many people think is even better, the ability to return multiple values from a function. Look at this getUser function. It doesn't just return one thing, it returns both a string and an integer at the same time. This bundles data together just like a tuple, but it's built right into the language, making your code super clear and easy to read.
All right, enough theory. It's one thing to talk about this stuff, but it's another to see it in action. So let's build a tiny little store inventory system to see how slices and maps really work together to solve a real problem.
So first things first, we need our inventory. A map is the absolute perfect tool for this. We'll use the product's name as the key and its price as the value. That way, we can look up the price of anything instantly.
Okay, now for the customer's shopping cart. They're picking things out one by one, which sounds like an ordered collection, right? So a slice of strings is the way to go. Here, they've grabbed some chocolate, and then they've grabbed some cookies. The order is kept perfectly.
And here is where the magic happens. We just loop through our cart slice. For every single product in that cart, we use its name to look up its price in our product's map. Then we just add that price to our running total. See how perfectly these two data structures work hand in hand? It's awesome.
So let's just do a quick final recap on our translation guide.
Anytime you're thinking, I need a list, in Go, you're going to reach for a slice. When you think dictionary, you're going to use a map. Need a set of unique items? Use that clever map with Boolean values trick. And for a tuple, you're going to use Go's amazing multiple return values. It's a really small set of tools, but man, they can do just about anything.
And this quote really gets to the heart of Go's whole design philosophy. The language doesn't try to give you a million different specialized tools. Instead, it gives you a few super powerful core tools and encourages you to master them and combine them in elegant ways.
Of course, this is really just scratching the surface. The next step on your journey is learning how to combine these collections with your own custom data types using structs, and then how to write really flexible code using interfaces. Once you get those down, you are well on your way to building some seriously cool back-end systems.
Hey, if this little translation guide helped you out and you're excited to keep going with Go, then do me a favor and hit that subscribe button. We've got a lot more explainers like this one coming your way. Thanks for watching and happy coding.